Yeah, thanks, Stefan. Um, good afternoon, I should say, everyone. I'm over in the United States. It's early for me, but today I'll be giving a short presentation on some of the best practices for using the Civil 3D connector for Quadri. We want to say goodbye to geometry and attribution loss is kind of my theme. So we're going to be going over, I'll quickly go over connected data environment because you guys have probably been inundated by that today. And then we'll talk about, traditional manual import and export and some of the deficiencies there from Civil 3D. Then we're going to actually get into the nuts and bolts and look at Civil 3D connector, and we'll push some data to Quadri, and then we'll take some data from Quadri and go back to Civil 3D. Um, so why do we care about a connector if we can import and export files? Well, we want a connected data environment. Traditional project delivery is extremely inefficient, and now that we are creating digital information with our design data, it needs to be shared with all of the stakeholders on the project. So traditionally, when you import or export files, not just from Civil 3D, but many applications, there's a lack of geometrical support, or what we would call a dumbing down of objects. For example, specifically AutoCAD, Civil 3D elements will get dumbed down to AutoCAD elements. So alignments become lines, tins become 3D faces, you lose pipe network connectivity, and the imports may fail altogether. Civil 3D can't really import that large of DWGs. And many of the attributes are lost. We have the extrinsic or external properties. This is the properties that you see in Civil 3D when you click on an object. We have intrinsic or internal properties. These will often be in the background, oftentimes associated with things like analysis. So pipe objects, for example, have a lot of internal properties. And then we have P sets or property sets. This is an additional functionality in Civil 3D that allows us to add any properties we want, basically. And this will show up in the extended data tab in Civil 3D. One problem, though, is that importing is traditionally kind of an all or nothing process. We really don't have the ability to filter or select data or information or objects. And actually directly importing a DWG into Civil 3D is not possible. You either have to reference it, which Autodesk calls an XREF, data shortcut individual objects, or if you want to insert the whole DWG, you can use the insert command and bring the file in as a static block reference. And I'm going to show a picture of this on the next slide. And then you can explode that block reference to get your objects again. But this can be very time consuming, and again, it's prone to crashing and can't really handle large DWG files. So where are we in the digital project lifecycle here? So we're just focusing on design to the CDE and back with Civil 3D and Quadri. Well, what does the connector really do for us? I mean, we can physically import and export a lot of objects. Well, it improves collaboration. And this is kind of canned language. This is what a connected data environment does in general. Enhances efficiency, automates workflows, increases project transparency and risk management, and helps us make data-driven decisions. But how does the connector workflow help us do this? Well, it enables us to deliver the most geometrically robust and attribute-rich objects to the CDE more efficiently. And this will streamline project delivery and infrastructure operations significantly. So traditionally, I don't know if anyone's familiar with Zoolander, but I sometimes felt like this as a designer when I had all of my project files, and it could be very difficult to deliver them. The contractors may want packages in different ways. I remember one contractor, we had 100 surfaces on a project, and we were using a tool that we could only put one surface in an XML file. So I delivered 100 XML files to the contractor, and they were overwhelmed and didn't know what to do with it. So then I got Civil 3D. As an agency, we started designing in Civil 3D, and as most of you probably know, you can put as many surfaces you want into an XML file. Well, then I delivered one XML file, with 100 surfaces in it, and the contractor was also overwhelmed. So part of this is enabling stakeholders to digest and curate the data in any way that they want to consume it. So we need to make sure that we deliver geometrically robust objects with as many attributes as possible, because we don't know how this data is going to be used in construction. We don't know how this data might be used 30 years from now in operations and maintenance. So here's an example of some of the geometry kind of breaking down and some of the connectivity not being what we would want from traditional imports. So here on the left, we have the original, this is a drainage file, so we have pipes and structures, and you can see I've selected a structure, but when I insert the DWG into a blank Civil 3 file, it is then a block reference, and I don't have any of my attribution. I can explode the objects, and then Civil 3D will recognize again that it's a structure, but we lose connectivity as well. So you can see this, there was one pipe network in this particular file. And when you insert a block and explode a block, it will take each structure and pipe and make it a separate pipe network. Obviously, we don't want hundreds of pipe networks. So that breaks down, but all is not lost. You can see here in Quadri, significant amount of properties, all of our internal, external. There is no PSET data on this particular one, but you can see all of these properties coming from Civil 3D now in Quadri. A lot of these internal properties are really difficult to even find in Civil 3D. You can see some of this stuff has to do with hydraulic analysis, for example. So now any stakeholder can access all of the data coming from Civil 3D, and they don't even have to have Civil 3D installed, right? We have Quadri. We can publish stuff to connect. We really want to just enable all the project stakeholders. So a big thing in roadway design, and specifically Civil 3D, is modeling of corridor components. You can use that same method of like inserting a block and exploding it. And Civil 3D will understand alignments, surfaces, feature lines, and corridors, but there's some serious performance issues here. I've never been able to insert a corridor file larger than about 10 megabytes. So your 20, 30 megabyte large corridor files, this traditional insert method is just going to break down on you. Corridor solids crash this workflow pretty regularly when sent with other corridor components. So if you must insert corridor solids with the traditional method, we encourage you to use the connector, but if you must, send solids from their own file. And QA/QC is crucial on imported objects. As you can see here on the right-hand side, I don't know, Stefan, we may want to zoom in on this one. I have a corridor and a corridor surface, and then when I insert it back into Civil 3D into a blank file, I see that my corridor surface has been geolocated incorrectly. It's almost, let's see, 2 or 3 kilometers off. So if you must insert into Civil 3D, it's crucial to have proper QA/QC. But we're highly suggesting to use the connector. So another one of the things that the connector allows us to do is actually kind of harvest some broken data. Not only is it going to let us get all the objects with all their attributes, it's very common for those of you who've designed in Civil 3D a lot, or those of you who've been delivered projects in Civil 3D, the dialogues on the left will look very familiar to you. Broken XREFs, couldn't find a pay item file, SHX files missing, which is where the sub-assemblies and assemblies come from. So organizations that use Civil 3D, they manage their file structure and XREFing and working folders for data shortcuts differently. I mean, they may use Autodesk Vault, Construction Cloud, Desktop Connector, or they could have just developed, an in-house document management system. So it's really not very uncommon for Civil 3D projects to get delivered where things are disconnected. XREFs are disconnected, data shortcuts are seemingly disconnected. But the good thing is that we don't really need a lot of these relationships to maintain our connector workflow. For example, we don't care about reference files because it's best practice to push objects into Quadri from the source file, because Quadri understands the unique object ID, or the GUID, and will not allow you to duplicate like instantiations of objects, so this can be very confusing when you are trying to push an object through the connector and it just will not come into Quadri, and that's because you've already pushed that object from a different task or a different Civil 3D file. So we can actually take advantage of some of these broken situations, I would call them. Data shortcuts are not really shortcuts. They are actually copying the objects into the file. They call them shortcuts because we can just grab one alignment or one surface or just a handful of objects from another file and bring them into our Civil 3D file. But it's very, very common to break the file pathing for the data shortcuts. You have to set a working folder, and when you deliver a Civil 3D project, this relationship may get broken. So one thing I do need to mention is that when you data shortcut objects into a Civil 3D file and then break that relationship, the objects are still in the file, but they will have different IDs. So you have to be very careful, because you could potentially bring the same object in twice, because Quadri will not recognize it as the same object. But this can actually be really useful for us sometimes. Maybe you don't have access to the source file where those particular data shortcutted objects are. Or maybe it's really more efficient to send many alignments and surfaces from one file, depending on the design workflow. Some people like to data shortcut maybe all of their alignments from their project into one file. In that case, it would be extremely useful for us to push data shortcuts. So it's kind of a case-by-case situation, depending on file structuring and design practices. So you can see here on the right-hand side, that box that just came up in data shortcuts. If you're familiar with Civil 3D, you might be confused because there doesn't seem to be any data shortcuts in there. But if you see this icon with the square and the arrow, that means it's a data shortcutted object. So although at face value, there's no data shortcuts in this file, we actually do have the data shortcutted objects. So this can be used to our advantage sometimes if we have like excessive file numbers. Just remember to use this data shortcuts very carefully, since they create new unique IDs. Okay, now we're going to actually get into the connector. Civil 3D to Quadri. Okay, first thing, we have to have Civil 3D and Quadri both open. So we're going to create a connector task in Civil 3D on the Quadri tab and the Quadri task panel. You'll click create task. And then you can select a summary task in Quadri if you would like. Also, alternatively, you can create the connector task from within Quadri. This is done by clicking the connectors tab, you click design, miscellaneous panel, then you click templates and select the default Civil 3D template or a user template that you had saved. Perhaps you have some custom conversion rules. You don't want to have to do those every time, so you want to save user templates. Next is settings. We'll click on settings. Here you can see the settings dialog. So import all pipes and structures as solids. If you don't check that, there'll be meshes. You can select whether or not you want to launch the conversion rule editor. And then you can select whether or not you want to remove those data shortcutted objects from pick objects. Also, you want to set whether or not this data is proposed or existing. This will set metadata on conversion into Quadri. All right, now we're going to click Select Objects in the Send Data panel. You can select any or all of the objects to send to Quadri and click Send to Quadri. Some tips here is click Select Objects button to select graphically from the model. And that is this Select Objects button at the bottom of the Select Objects dialog. This button will add objects to your selection set if you have not selected them here, but it will not remove. So it doesn't sync your selection. It just adds any objects to your selection that you have not selected in the reference. And block references are very, very often not wanted model elements. It's very common for there to be kind of junk blocks on 0, 0. Like we've got some, north arrows, some cross-section layout blocks. So it's quite common to not send the block references across unless you know that those blocks are something that you want. Okay, conversion rules. So here are the default conversion rules from Civil 3D to Quadri. Now, they are set up to key in on 3 different things, basically. Object type, so you can see here the orange squares. This is every single object type coming from Civil 3D. Alignments, parcels, points, structures, pipes, feature lines, auto feature lines, corridor surfaces, station equations, solids, everything. So we should have all of the Civil 3D object types covered. We also are keying in to convert by style or style name. Civil 3D is used in Europe pretty extensively for drainage. So you can see some drainage style names there. And then we can key in directly on the object name itself. Very common in Civil 3D for things to be called top, pave, datum, daylight cut, daylight fill. So these default conversion rules for the Civil 3D connector are actually really good. But if you want to get a little more granular, I would say the next most useful attribute, in addition to object type, style, and object name, is layer. A really good tip is to use the create rules from preview model for more detailed mapping. And it exposes what object geometries and attributes are available to you. So when I hit create rules from preview model, the data blob populates from Civil 3D, and I can see that I have curves, multi-curves, points, solids, and surfaces in this particular file. So I can convert by those individual attributes, or you could convert by multiple attributes. So you can get something a little bit more detailed that looks like this. So we are mapping most of these by object type and layer. And there is even a few, like surfaces, we're mapping by object type, layer, and style. So this will help us get a lot more specific and not just putting every surface on kind of a more general feature type. Okay, attribute mapping. This is the reason that Civil 3D is my favorite connector. In the source attribute, we have legacy tag value list, and this is by default. You do not have to map this. And it is mapped to the generic property list. We do not have to discretely map out all of the attributes. The Civil 3D connector allows us to push the entire list with just this one row. So that is a really, really, really amazing thing about the Civil 3D connector, that other connectors are a little bit more burdensome. So in order to see this attribute view in view mode, we're here at view attribute conversion per object. And if you wanted to map discrete attributes, sometimes we don't want to send everything. Maybe there's 1,000 attributes. So if we want to discretely map them out, we can pick the particular attributes we want to map here, or I would suggest to use the multiple attribute dialog. This brings up a dialog box and allows us to select any and all attributes that we would want to match, or want to map, excuse me. Another tip is if you see an attribute that starts with asterisk A and then it has a number and a vertical bar, like this format here, that means that these came from pset data. So either it was a corridor solid or somebody put some pset data on the particular object. Okay. Another thing we can do, let's see if I want to, yes. So for example, Civil 3D is not always fully consistent with the way that it numbers its property set attributes. So for example, this one's asterisk A2 baseline name. Sometimes it's possible that that could be asterisk A3 baseline name or asterisk A1 baseline name. So what we want to do is, I know a substring that I want to match, but I'm not 100% positive on the formatting of the attribute that's going to come from Civil 3D. That's where I use this edit name tool. And in select method, you will click match substring. And you can see here I put in corridor handle, and it's going to map that property there, asterisk A1 corridor handle. And it's going to map that attribute regardless of what the extraneous text is, because we're just matching this corridor handle part. All right, so here's a quick video. So for some context, I have already brought in an existing surface and one corridor into Quadri. Now I'm in another corridor model in Civil 3D, and I'm going to send across. So I'm showing you the files that I already sent across here. This is existing terrain. And now I'm going to use the connector to send another corridor as well as a pipe network. Just want to show in Quadri here, we now with our IFC feature catalog are automatically mapping source colors. So you can see the colors match Civil 3D without any extra work. All right, so now we're going to go ahead and create a task for this corridor. And we're going to look at the settings. I think I decided not to launch the conversion rule editor. Yep. I'm leaving the data shortcut objects in the model for conversion. I'm selecting objects, selecting everything, but I don't want the junky block surfaces at 0, 0, so I'm going to deselect those. But I'm just kind of showing how the select objects dialog categorizes by object type. I'm running a little low on time, so I'm going to kind of... All right, so now that I've brought the corridor into Quadri, you can see that then that adjacent corridor then shows up. And this is the method we'll use to create our project information model. And here I sent some pipe network objects across as well. Okay. Okay, so we've, in that manner, created a project information model, brought all of our design data in. Everybody's collaborating on it, and now maybe we want to send some stuff back to Civil 3D. Maybe design wants to iterate. Maybe we need to deliver in Civil 3D, but there's a lot of reasons we might want to go use the connector to bring objects from Quadri to Civil 3D. So the steps to do this is you create a connector task in Civil 3D, name it uniquely, or you can create the connector task in Quadri as well. You want to select objects to send with the dynamic query, and this is the same object selection dialog throughout Quadri. So we can select based on tasks and then get a little bit, dive down a little deeper to specific objects or even a specific location in the model. So I'm decided to grab the corridor file and the proposed drainage file or task. You can see then you can even click on the count if you want to select specific objects. So in this case, I have everything selected in those two tasks. But if I wanted to only select one out of these three geotechnical stratums, I would click on this count here. Yeah, for example. And then if you would like, you can modify the conversion rules. The default rules are pretty good, but we'll go over that here in a second. And then in Civil 3D, you would click select task and receive the data. And then you would click receive from Quadri. So the rules for conversion from Quadri to Civil 3D are under the input drop down in the rules panel. So these default rules, they'll map the most common feature types. The destination sub attribute must be assigned an object type. So this is specific to the Civil 3D connector, and one of the only things I actually don't like about it. We're kind of constrained as far as the different amount of object types we can send back to Civil 3D. You can see here alignment, for example, tin surface. So in order for Civil 3D to understand what you're sending it, you have to map an attribute onto the legacy tag value list, call it object type, and it has to be camel cased like that with no space. So capital O, capital T. And there's a lot less object types available for us to send back. So if tin surface is the only surface available, for example, we can't specify corridor surfaces. So pipe networks, solids are understood. So pipes, object type pipe, that'll be a solid. But besides structures, pipes, pressure pipes, basically pipe objects, any other solids you have will not be understood as anything other than just a solid. So coming through the API through the connector, Civil 3D will not understand what a corridor solid is. It just understands it's a solid. So if you have a non-drainage object that is a solid that you want to bring it back into Civil 3D from Quadri, make sure that you attribute object type solid. So now we are going to start with a corridor file in Civil 3D, and I'm going to select that task that I just created so that I can receive those objects from Quadri. I got like 1 minute, 2 minutes left. And I'm almost done, so this is good. It's my favorite part of the connector, actually, watching all the objects just populate in there. And these objects didn't have to come from Civil 3D, obviously. This existing ground could have come from anywhere. We trimmed it out in Quadri, brought it back into Civil 3D. Now we have a really nice little Civil 3D model in here with our pipe network, existing ground, and 2 corridors. So, summary. Use the Civil 3D connector settings to include data shortcut objects, if appropriate. Shortcut objects will not be recognized by Quadri as already existing in your model, so be very careful on converting them. Include shortcutted data carefully when in dealing with excessive file numbers or discrete designs. You can select objects graphically with the Select Objects button. Block references are very most often not wanted model elements. The most useful conversion keys are Civil 3D object type, style, object name, and layer. And use create preview rules from model for more detailed mapping and to expose object geometries and attributes. If you want to map multiple attributes at once, which the Civil 3D connector by default maps them all, but if you want to discretely map them, use the multiple attributes tool. And if you have some variation in the attribute naming, use the edit name tool and match the substring of the part of the attribute that you actually are sure that you're going to see. And this one's super important. The destination sub attribute must be assigned an object type from Quadri to Civil 3D.